This
Thank you so much
conference will
for
now
joining.
be recorded.
I'm so happy to be with you all today, and thank you for taking the time on this Friday in many time zones across the world to spend this time with us. Thank you so much to the great team at SGAC and celebrating the space generation. I've been honored to serve for the past few years as part of the board of advisors for the Space Generation Advisory Council, and I'm a former member back when I was at the right age and career path to be a member. I've benefited greatly from the community that SGAC creates, and I look forward to participating in SGAC events for years to come. I appreciate the introduction, and as he mentioned, I serve as the director of the Space Enabled Research Group. We are a team of researchers, scholars, students, and research staff. We are basically working directly to ask how we can use technology from space to support sustainability both on Earth and in space. And much of our work is done in collaboration with people from around the world, including in the regions of Latin America and the Caribbean, as well as in Africa, the Middle East, Southeast Asia. Since about 2005, I have been doing academic research asking how are countries starting new space programs, what benefits do they hope to gain from these programs for national development, and what strategies are they taking to train new engineers. My doctoral research went deeply into this topic at MIT, where I did a number of case studies about the early years for satellite technology in several countries, especially in Africa and the Middle East and Southeast Asia. Now, this study was first done in 2011, and I'll highlight that a lot of great things have changed since then. When I first started talking about space programs around the world, I focused a lot on how countries worked, particularly on small satellite technology, which we'll talk about in a few minutes. But I'll highlight that today there are so many different activities countries can do to get involved with space. So I'm first going to show a few examples from our Space-Enabled Research Group, and I'll highlight how we collaborate with people around the world to apply space and design space innovations that are relevant to society. But I'll also highlight examples and advice for how to design a space program in your country. Let's continue. The mission of the Space-Enabled Research Group is advancing justice in Earth's complex systems using designs enabled by space. This means that we are thinking about a large-scale concept. Of course, the word justice is a powerful word, and we must spend a lot of time thinking about what it means to us. For us, there's a few definitions of justice. The first is that space technology and space itself is something that everyone deserves to benefit from, because space is a global commons, in a sense a universal commons, that belongs to all people equally. So we would argue that a just world is one in which everyone has equal benefit from space around the world. We also highlight that a just world is one in where we address historical injustices and particularly move toward a world where people have equal opportunity to basic human needs as well as to societal development goals. One of the best ways to describe these goals is the United Nations Sustainable Development Goals. Hopefully many of you have seen these before. They are in activity between 2016 and the year 2030. These are some of the key goals that countries are working toward for national development, either these exact goals or something very similar, because the United Nations has curated this set of activities along with many countries around the world and many stakeholder groups. And many countries have adopted these as part of their vision for development between now and 2030. As you can see, they address both basic human needs, ensuring that we reduce extreme poverty, people have access to food and healthcare and education, but it also addresses global systemic challenges, such as addressing climate change, thinking about our global system of consumption and production, and the fact that we produce a lot of waste in that system. Thinking about the need to have sustainable jobs and economic growth, access to energy, but also ensuring biodiversity in the ocean and on land. So in our work, we ask how we can use technology from space to support these global goals, but also to support sustainability in space itself. If you think about some of the challenges that we're facing as a human race right now, one of the main ones is climate change, and it's affecting different groups differently across the world. But globally, we all should be concerned with, of course, the great increase of activities, especially greenhouse gases. Here you see carbon monoxide and carbon dioxide. They're a result of the way we live and travel and produce energy and send information around the world, and goods as well. So we have a challenge, which is that our global economic system has produced a large-scale pattern of long-term waste, which also has negative impacts, especially on regions near the equator, near the poles, where they're experiencing right now the impacts of climate change due to human activity. But in a similar sense, we in the space community can also think about the way that our human activities have created a potentially unsustainable set of waste actually in orbit around the Earth. So here you're seeing an animation. Hopefully it's coming through as an animation. If not, at least you can see the pictures. But we're isolating the fact that there are a number of human-created objects that are in orbit around the Earth, and many of them are pieces from formerly operated satellites, and a large number of our satellites are not managed to be able to be destroyed safely at the end of their life. So there are large amounts of debris, either from satellites or rockets or former space missions, as well as a few natural objects. So we have a great challenge to address this, and I'll show you some of the work our team is doing in this topic. But whether we're talking about climate change or space sustainability and managing the space environment, there's some key challenges, and we need every country, no matter where they're from, to be participating in this important challenge. Another way to think about sustainability is asking, what kind of challenges will we create in the future? I expect that humans will be living and working in places like Mars, on the moon, on asteroids in the future. People from all over the world may be involved with these activities. And in this future, we can ask, here's a location where humans have not yet created an unsustainable stream of waste, but we do want to ask how that might look in the future. Can we design communities, both from an economic point of view, a social justice point of view, and an environmental point of view, that are sustainable in places like Mars? And if we think about that lesson, can we bring it back to Earth as well? So I would encourage you, no matter what country you're from, to say, how can you be part of this question? How can you ask how the knowledge from your community and your culture can contribute to sustainable human activity on Earth and in space? In Space Enabled, we identify these 6 space technologies that are currently useful to support sustainability on Earth and be part of the thinking we do for sustainability in space. This includes satellite Earth observation, satellite positioning and navigation, human spaceflight and microgravity research, satellite communication, space technology transfer, and research infrastructure. We also focus a lot on using several different research methods to address how we can provide research designs and research findings in improving the way we use space technology for sustainability on Earth and in space. So our team has people from several backgrounds, including design and art, social science, complex system modeling, satellite engineering, and data science. So we have a variety of sets of knowledge in our team, and it means that we are bringing together several different research methods. We try to combine them as needed in our projects. I'll show you a few examples of that as we go. Our work also is built into collaborating with people from a variety of types of countries, and especially in Latin America, in Africa, in the Middle East and Southeast Asia. And we are always open to looking with new collaborators, how we can apply space technology in collaboration with people who work on development or sustainability on Earth and in space. That includes people from international development organizations, people from local and national governments, people who work in universities and nonprofit organizations, as well as people from companies that have social entrepreneurship. So you'll see a few of those examples in our work today. I want to give credit to my team. These are the current members of the Space Enabled Research Group, and several of them have their PhDs and are research staff, and some of them are people working on masters and PhDs. We also have a number of people who are in their first degree who are coming into our team this summer who aren't shown here, but I'm so thankful to lead this group, and we have the opportunity to work on projects together, and I'll give you a few examples now. Our work comes into 3 key categories: designing systems to make space both accessible and sustainable, exploring the links between technology and justice, as well as designing space technology to support sustainable development on Earth and in space. So let me give you a few practical examples, because actually I think the projects that we do are relevant to many countries that might be interested in starting new space activity, either because we are in collaboration with countries around the world or because we're identifying ways to adapt current space technology to local areas around the world. The first example is a technology development project, and we're working toward exploring the potential of wax as a potential fuel for small satellites when they're in space. And I want to give credit particularly to Dr. Javier Stober. He's the first person pictured all the way on the left of the screen. He's done his PhD at Stanford in a group that demonstrated that candle wax, the same kind you might use at home in a candle, can be used as a rocket fuel. So it's been studied for several decades, first at Stanford and now around the world. It has not been studied as much in the microgravity environment or the environment outside Earth's atmosphere in terms of vacuum and microgravity interactions. So we are going to study the behavior of wax in different states, solid and liquid, and see how it behaves in both the microgravity and vacuum environments to understand if it has the features we would want for a fuel for satellites in space. This is particularly interesting if we could use it as a way to deorbit satellites. And I'm showing some of the other team members that have worked on this project. Now, many satellite fuels are actually dangerous for humans to handle. So the example you see here shows people wearing special suits to keep themselves safe while they work on a fuel that could be toxic. But with candle wax, perhaps you're familiar with interacting with it, it's very simple and non-toxic. I will give the point that it actually comes as a byproduct, in many cases, from oil refining, which means actually it's very low cost. But we also are interested in alternative sources, and one example is actually naturally occurring beeswax. So we're interested in studying both candle wax, which is affordable, as well as beeswax. Here's an example of a video coming from previous research by teams such as at Stanford, and they're highlighting the fact that we can show great benefit of actually burning candle wax in the lab and showing that it can provide thrust for rockets, especially from launching from Earth up. Now we are doing further research to explore its behavior, not just for rockets, but also for satellites, so it'll be in space. Particularly, we're comparing both paraffin wax and beeswax, and we want to study how it behaves differently in the laboratory, in thermal vacuum chambers, in a microgravity research plane, and on the International Space Station. Eventually, we hope to also explore how it would behave all the way on a satellite mission. That's coming up in our future research plans. I'll show you a few examples from our laboratory research, partly to highlight this is a type of research that builds on a lot of existing knowledge, but it's very affordable to participate in. Here we have a relatively affordable laboratory setup where we've melted candle wax. It looks like water, but actually it's wax in the liquid state. And we're spinning it to see how it behaves because we want to get a particular shape, which is a cylinder with a hole in the center. This has been shown from previous research to be a very ideal approach for having the right geometry for burning. So we're very excited with this image because it shows we've achieved with a very simple setup that could be reproduced also in space, the ability to show that liquid candle wax can be shaped and then eventually solidified into this very efficient shape for burning and combustion. We've been further testing to find out exactly what happens during the solidification process. If you're gradually cooling the wax, we want to understand every step of how it behaves in terms of thermodynamics, because this will let us also predict how it may behave differently in microgravity as well as in a vacuum. The reason it behaves differently is that there are different features of the thermodynamics. If you don't have air exchanging heat with the environment, then you're radiating the heat, and so you'll have a different impact. But also with microgravity, you have different dynamics in terms of how these kinds of systems cool. So we're studying that very carefully, because all of that can go into the design of a future system using wax as fuel. To get into the microgravity environment, we've been thankful to collaborate with different teams, and actually the first team that invited us to join was from the UAE Space Agency. And we were so thankful for the invitation, because we wanted to go onto a microgravity research flight, and I hope you have an opportunity to explore one of these flights in the near future. It's actually more available now commercially, that people can ask from a company to pay to have access to a flight like this. And as you go very steeply up this hill in the sky, and go over the top for about 20 seconds at a time, you get microgravity experiences. And so it's possible to do that over and over and get several research results. And so our colleague, Dr. Stover, helped us design a research test article that will be studying the behavior of wax or wax analogs inside this plane. And several of our students, including Christine Joseph, were able to fly on the plane. This particular shot is beautiful because actually the event's happening in the US, in Orlando, Florida, but all the colleagues you see on the flight are either people from the United Arab Emirates Space Program or students that they invited to join for that flight through a contest opportunity. And we were the guests. We were so thankful to join. It was our first microgravity research flight. And here you see my colleague, Christine, thanks to our colleague who's also helping us operate our experiment. And Christine is both running the experiment, but also enjoying some of the microgravity flight. But you're seeing our test there showing our analog for the liquid wax. And we're testing to see if we can get that same shape that we got in the lab, trying to understand if it behaves a certain way and cools a certain way as compared to the project we do on Earth. We're continuing this research. We actually need to repeat it over and over again. And it's really an invitation for others because we also hope in the future to have more teams studying their own local beeswax to understand how their particular type of wax in their country behaves relative to what we see here in the United States. One of our colleagues, Juliette Wanyeri, who recently graduated from Space Enabled with her master's degree, had a chance to do a second flight, and we got some additional results, this time identifying that if we change the speed of rotation, it helps us understand how much energy is required to get that shape we're looking for, which is the cylinder with the hole in the middle. And I show all this to show that the kind of research we're doing is exciting and innovative, but it's not so expensive. And so it's something that people can get involved with even if they're new to the space field. And there's opportunities to do microgravity testing, both in planes, but also in other analog environments. More on that later. We'll highlight another topic here to show that one of the benefits of having more propulsion for small satellites is the opportunity to also help reduce space debris and actually deorbit satellites or send them back into the atmosphere to be destroyed safely after they're finished. This is part of our bigger goal to help make space more sustainable and accessible. And we're also working on a topic of the space sustainability rating. We're working on designing this system that will help to encourage responsible behavior by operators of satellites in space. And here I'll explain this is a big project with collaboration from the World Economic Forum, the European Space Agency, a company called Bryce Space and Technology, and the University of Texas at Austin. We're working together over several years to design this system. It's similar to what you might have heard about. There are various commercial systems, such as LEED, that are examples of rating systems for buildings. And those give you a score if you are behaving very well and showing that you are not making a problem in the atmosphere or the environment with the building. In a similar way, we want to make that for satellites. So we're working on creating this space sustainability rating, and we're seeking to give an award, basically an incentive to organizations that voluntarily do what they can when they design their satellite, when they operate it, and when they end the life of the satellite by deorbiting it safely or putting it into a graveyard orbit. Those are choices they can make and things they can do throughout the mission to actually reduce the threat of either collisions in space or of creating space debris. There's some practical things that a satellite operator can do. They can check where do they plan to operate their satellite and what satellites have been operated in that location previously or currently, and how much new congestion will be created when they choose their orbit. They can also check how the materials that they use and actually the size and the shape of the satellite make it easier to track from the Earth. And they can follow a number of standards that have been provided already through international collaboration and through many bodies around the world. I want to highlight the work of the United Nations Committee on the Peaceful Use of Outer Space. Many of you learn about this activity because, in fact, the Space Generation Advisory Council is a permanent observer of the United Nations Committee. And so many of you have had a chance to either hear about the updates of the committee, and some people get a chance to visit and watch them in person. There are about 90 countries that are members of this committee, and this is where major space law discussions have been occurring since the 1960s. And this is one place where some of the key guidelines to encourage satellite operators to operate satellites with the least space debris possible have been happening for many years. And so there are a set, for example, of 21 guidelines from the United Nations Committee on Peaceful Use of Outer Space that are guidelines to encourage the long-term sustainability. So our rating system will ask, how are people following these types of guidelines? Hopefully some of you can get involved with this activity or find out who from your country is participating in these meetings at COPUOS, because there are ongoing discussions about how to implement these long-term sustainability guidelines. Earlier, I showed some examples of my team's work in microgravity research, meaning we have been testing our wax propulsion technology idea in microgravity. And one of the things we've asked in our research also is, what does it mean for different countries to have access to microgravity research, both now, but also because things will change in the future. There'll be more businesses, more companies, and more governments involved with microgravity research. It's a great privilege and opportunity for university students to send their experiments either on planes or rockets or perhaps to space stations. So Christine Joseph studied in her thesis, will there be more opportunities for more countries to send this kind of research to microgravity in the future? So currently one of the best places to do long-term microgravity research is the International Space Station. And it's a great example of collaboration where actually 5 main partners are involved. This is the United States, Japan, Russia, Canada, and a group of European countries who participate as a group. Now, despite the fact that there are 5 main partners, many countries have had the opportunity to send research to the space station. So I think for looking historically and at several decades of collaboration to both build and to operate the space station, it's been a great success, and we can really celebrate how much new international collaboration has come. But I would also say we should look for even more collaboration in the future, because after around 2030, we expect there'll be some change in the operation of this space station. Perhaps it'll be retired, it may be divided into different operational management rules, and we expect to see more companies also putting up new commercial space stations, and more governments might be involved as well. Of course, we know that China also has operated a space station, so we're seeing more kinds of space activity happening in low Earth orbit. And what does this mean for emerging space nations? I hope it means that there are more affordable opportunities for universities and research institutions around the world to send their research to some space station, whether it's the ISS or other commercially operated locations. Currently, as a US university, I'm so thankful that I can apply to NASA because my university is able to participate in research projects that can be requesting either transportation or other research funding from my government. And this is partly because of the way the ISS is designed to support particular government programs. In the future, we hope we might also see programs that are kind of flexible to different governments. So it doesn't matter where you're from, but it matters if you're able to access or afford the activities. We also want to see programs that provide funding to support those who may not be able to afford, but do have good research ideas. Our team is looking forward to, in the future, sending our WAX experiment to the space station to join these kinds of experiments that are already happening there. I also wanted to give some examples of other lower cost ways to do microgravity research, just to expand the options for people on the line. This is an example of a system called a clinostat. It's a relatively affordable system that you can set up in your own laboratory. And it shows, for example, a way to test the behavior of objects that are subjected to altered gravity. So it's a simulation for microgravity, and you can see the plant here is rotated such that the plant isn't experiencing typical forces of just being pulled down toward the center of the Earth. The different parts of the plant gradually get exposed in a consistent way to different directions of gravity, and therefore it's kind of like the experience of microgravity. So this is one example of an affordable lab-based test. People often study the experience of humans who do bed rest studies. It's another example where, without actually going to space, we can see people in an analog environment that is very similar in many ways to being microgravity. Further examples include drop towers. There's examples in Germany. And these are the kind of systems that can give you a few seconds of microgravity. So it doesn't have the same impact of being in the ISS, but of course it can be more accessible to people around the world. And drop towers can be added in new places around the world to expand the options for who can access them. This is a view from inside the drop tower. Even though it's a simple concept just to drop something and have it experience free fall, it still can be very careful because you want to figure out how to recover the object that's dropped safely, but still allow it to have the free fall experience. But all of these are ways to participate in space research without necessarily needing to afford to send something all the way to space. So these options are very relevant to countries that are getting started. In the research by Christine, she asked the question in her thesis, will there be more options that are affordable for microgravity research, especially for university scholars in countries in every region of the world? In particular, she identifies these two ideas that we want to see increasing economic openness and administrative openness for future microgravity activities. So one example is, we think that if there's a single government operating a space station, they're likely to sometimes restrict their activities to their own country. But if you have multiple countries working together, hopefully that expands who can be involved, maybe even to people from around the world. And if you have a mixed public-private partnership, it might be the most likely to be both administratively open, meaning people are allowed from all over the world, and economically open, meaning there's some subsidies to allow those who can't afford to get involved a cheaper access. So we hope that there will be a mix of these different types of space activities, especially in low Earth orbit communications and studying some of the early or enabling some of the early activities of countries in space. There may be a combination of commercial, public-private partnership, and full government activities. And so look for how that might be an opportunity for your country in the future. This, I think, is something we'll see in the next 10 to 20 years. Another big idea is that there's another way to be involved with space, which is actually helping us plan a future effort in the area of space traffic management. So, of course, I showed, for example, there's many satellites operated, and there's a lot of trash or old parts of satellites or parts dropped from rockets that also are in space. In the future, we'll need a more robust system to manage the traffic in space, and actually we need every country who's involved with participating in space to have a voice in designing this future system. There's a few countries traditionally that play a key role, especially the United States, in monitoring objects in space, and currently the US military actually plays the role to help call operators when there's a potential for satellite collision. And that's worked okay so far, and we're very thankful for the service they provide, but in the future there should be a more global system. So there's another way to help create the future of space, which is to help study and then get involved with designing future space traffic management systems. My colleague Miles Lifson has been involved with asking people from countries who are considered emerging space countries, and since they're developing their space programs now, what are their views on how this should be designed in the future? We're particularly talking about the set of technology and regulatory provisions to promote safe access in outer space. And you can read a study by the International Academy of Astronautics from 2016 to learn more about the technology and the definitions of space traffic management. In this case, Miles had a chance to ask several research questions, and he did interviews with people from emerging space countries to find out what are their opinions about how we should design the next or the future global space traffic management system. Particularly, we were trying to find out if they had questions or ideas about how it should be designed, what processes, as well as what technology impacts it might have on them. So I talked to people from a number of countries, including South Africa and Kenya, Indonesia, Thailand, the UAE, Vietnam, Argentina, Bolivia, Chile, Colombia, and Poland. And it gave us a little hint to the kind of themes that are important to people around the world as we think about the future design of an STM. Here are just some examples of the kinds of ideas they shared. We asked, for example, do they have concerns about the consequences or impacts of an international space traffic management system on their country's operations in space? Were they worried that some people would be experiencing restricted ability to operate as they desired, or they would cede some control over foreign assets? It is possible that if there's more coordination to operate satellites with more communication across countries and perhaps more data sharing, there might be more rules put in place. And of course, in that case, we would want to see countries around the world coordinating closely so that those are really done through a congenial process. And I think we see a great opportunity from previous work by the United Nations Committee as well as other groups to help establish this kind of experience. And there's a lot of data sharing happening already by satellite operators voluntarily to give us an example of what can be done. So we've continued to publish the findings of these interviews, and it'll come out in the thesis of Miles Lifson and several conference papers he's been writing. So if you're interested in more information, let us know. But just to highlight, this is both a technology and a policy question. We need people studying how to do future technologies such as active debris removal, or techniques to better monitor satellites from Earth, or techniques to better deorbit satellites if they're already in space. And so we need a lot of research in this area, and there's great opportunities for your education in the future. Another example I want to highlight is how we currently support sustainable development between humans and the environment using systems enabled by satellites, especially satellite Earth observation. So I'll show a few examples of the projects, and I'm highlighting several of the students here: Neil Gaikwad, Pratima Muniappa, Ufumo Obwimera, and Jack Reed. They're working in the countries of India and Benin in West Africa, as well as Brazil. And we have projects directly in collaboration with local people, identifying how they'd like to apply satellite-enabled technology, including Earth observation and positioning, in their local development activities. For example, Neil's working to understand how he can use satellite data that informs us about impacts of the environment on farmers in India. He's actually grown up in this region where there's a lot of farming, and he's interested in understanding how farmers can use knowledge from satellites as well as machine learning to help keep track of what the knowledge means, and to understand economic activities happening in the environment that affect the price of crops. So ultimately, he's designing an app that will also collect information directly from farmers as they take pictures and report impacts to their crops from things like floods or lack of rain. And he's trying to figure out how to best inform decision-making that they have to do about what to plant, as well as about how to market their crops. They exchange them for food and for money. On another part of India, my colleague Pratima, she's working with a community that has traditionally had a beautiful technique of actually using living tree roots as part of their local architecture. This is the Khasi community in the Meghalaya state region of northeastern India. And they have a beautiful tradition, but there's also the question of how this knowledge will be maintained for generations to come. So Pratima is using tools from satellite Earth observation as well as satellite positioning to make an app that can be used not just here, but in many communities around the world to actually record knowledge from very traditional communities that have a beautiful connection with nature and have knowledge that may be endangered due to changes both in climate, but also in policies that affect the conservation of the forest. Of course, there are people from the community who may need to move also to find jobs and opportunities, or may be forced to move due to government policies. So the knowledge that they have to do this kind of architecture is actually endangered. So Pratima is working to help preserve it with space-enabled designs. In the country of Benin in West Africa, we're working with a local company and several university scientists to understand this community on the lake called Nokwe, which is one of the major lakes near a major commercial center, two centers in southern Benin. In this area, they're very impacted by the flow and the growth of an invasive plant. It's actually from the Americas region, but it's been active in many countries around the world, and it causes a lot of blockage of waterways. So we're using satellite-based observation to help this company track the growth of this invasive plant. They actually harvest it and use it as a tool and part of a product to clean up oil waste. So very interested in this topic of how they can traditionally and then over a long period continue to use satellite observation as part of their business planning. Ultimately, we're going to work with them to design an online system that will be easy to understand and that uses satellite data and gives them updates regularly on the growth of this plant, but also on other impacts to water quality. And we'll be helping them set up local water quality sensors to understand the temperature and oxygen level and flow rate of the water And all of this will be working with local scientists who understand how these features impact the growth of plants and the overall health of the system. Finally, in Brazil, this is the city of Rio de Janeiro. They have a great tradition of using satellite data to manage their very diverse ecosystems of mountains and rainforest and urban areas and beaches. And my colleague Jack Reed, who you can see in the far left, is working with local professors and university scientists. They're studying the health of mangrove forest and the impact socioeconomically to local communities, because those communities depend heavily on using those mangroves as a breeding ground for fish. So we're using satellite data and building a model that can be used in many of your countries as well to ask what's happening in the environment, how is there social impact, perhaps vulnerability for people if there's a loss of ecosystem benefits like forests in the environment. What are the policies and human decision-making in response to that loss? And what are the technologies, such as satellite data, to better understand and monitor that change? So this kind of system is being used both for environmental monitoring, but also we've been adapting it lately also for COVID, because during this period of the pandemic, we can add a module of this model for public health. And we've been collaborating with public health experts to see if you also want to understand how public health is impacting society, you can add that as part of the same model. So I've given you several examples showing how space-enabled designs are used in our space-enabled research group, looking at issues of expanding access to microgravity research, our own work to think about innovations that are affordable but also highly important for possible new propulsion systems for small satellites. I've shown you how we can get all of you involved with getting the future design of a space traffic management system, and the fact that every country can improve your use of satellite-based Earth observation and positioning data as part of local problem solving. So let's focus also on the topic of today, which is how you might consider all these great opportunities and actually design a space program in your country that can use these space-enabled technologies more effectively. So early in my research, especially in my PhD work, finished around 2012, I thought a lot about how countries have been designing space programs. And I did about 100 interviews with people from several countries in sub-Saharan Africa, in the Middle East, in Southeast Asia, later in also Latin America. So what I'm going to show you is a summary of lessons that I learned from many of these countries. And if I have time, I'll tell you a few of their stories. I actually start with this picture because it's a way of organizing any kind of engineering or design problem. And it's coming from a tool called system architecture. This just means that you're imagining that you need to build something very complex, like a new program for a government or a university for space. And the blue box shows the things you're in charge of. If you're in charge of designing this program, that blue system boundary is what you can control. Everything outside the blue box, you can't control. So you have to figure out how to keep track of what's happening outside the box and how it affects you. Any kind of complex system that involves technology and people and organizations will have stakeholders. These are people that are interested in what's happening in the system or impacted by it. And the primary stakeholders will have direct decision-making authority. So let's assume, for this example, that you are the primary stakeholder. You have the full control to design this program. So let's use that as our example in this discussion. One of your goals is to identify what are the objectives of your program. There's actually a lot of options. I showed you previously, lots of choices. You can focus on local environmental challenges and using satellite data. You might be interested in expanding the role of your country in international space policy discussions. You may be interested in the topic of how you can expand education or basic science research in your country. So one question to ask yourself is, what are your high-level goals as the primary stakeholders? We'll go into that in more detail in a minute. The next question is, what are the functions and forms? Meaning, if you set your top 3 goals, the functions are the activities that you and the space program will do to meet those objectives. And they should be observable and measurable so you can know exactly when you've met the objectives. The forms are all the tools you'll use to perform those functions. That's organizations you may design, people that will be hired and trained, physical and virtual objects, so software tools, as well as facilities. It's also the programs you organize and the methods you use to do hiring, training, communication. All those are forms. One of the key lessons of system architecture is that you should think about the objectives and the functions before deciding on your forms. Meaning, you don't start by saying, what organization do you need? You start by saying, what are we trying to achieve? How do we know if we've achieved it? And what are the functions and activities we need to do? Then you can ask, there's like a variety of forms of organizations or people that might be able to do this. And the best thing to do is to compare quite a few and choose the one that's best for your situation. Keeping in mind that there's these constraints and opportunities outside your blue box that you have to consider. So let's talk about this idea of context. This is everything outside the box that you can't control. If you're starting a new satellite program or space activity in your country, you're also surrounded by other organizations, by an environment of other laws and government agencies and educational institutions that are part of your supporting context. And there's a national and international context. So before starting to plan a new space program in your country, the first thing you would want to do is actually study these other contextual levels. What's been changing lately in the international space community? I've just given you a few examples about what we expect in the next couple of years in microgravity research and low Earth orbit commercial activities in space. So study that by looking at news, by reading about the activities of your own country and neighboring countries, and that will give you ideas of what kind of opportunities or constraints you have, especially in the areas of technology, policy, collaboration, and economics. Just to give you an example of what I'm sharing here, at the national level, you can find out what's happening in your own country. Ask questions such as, is there already a space policy infrastructure? Is there an organizational mandate that one group in the country has the requirement from the government to work on space issues? Is there already a regulatory framework? If not, those are things you can compare from other recent countries that have started space activity and see how they have designed those. You can also ask, what are the security concerns? What are the priority industrial areas of the country? And what's the current technical infrastructure in both information technology or manufacturing and research and education? Studying all this for your own country helps you decide what's already in place and what needs to be added as you start to develop objectives for your space activity. In the middle, I have this idea of leadership style and vision. As I studied other space programs, I noticed that it was really important to understand what kind of leadership was there to set a vision for the future. And there have been a few key leaders. I can think of Dr. Maslan Ahmad, for example, who started the space agency in Malaysia. You can look at her life story and see that she played a key role in communicating the importance of space and helping her country see that they could set new visions, such as sending the first astronaut from Malaysia to space, and also being able to do a small satellite project even in the late 90s. And so her vision as an individual played a key role to make it possible to go forward. The next step is to talk about stakeholders and to ask three key questions, especially for the primary stakeholders and for those they hope to benefit with their work. What problems or desires are stakeholders facing? So if you're starting a space program, it should be to address some need. And you want to figure out what that need is before you start to design how you're going to support that need. Now, usually stakeholder needs are big. You might be thinking, well, in our country, we have concerns about the impact of invasive insects or plants. We have concerns about climate changes that are affecting our overall health and agriculture. Maybe there's concerns about water access. So if you have those kinds of challenges, or there's issues around the migration of peoples and questions about having a positive trade relationships across different countries, those are all large needs, and actually space may not completely solve them. So we want to say, okay, given those needs, what kind of outcomes are stakeholders working toward? And what can our system of our space program do that's partly addressing those needs? So usually the objectives for your system won't completely satisfy the needs, but you want to show that they're actually motivated by and linked to those needs. For example, you may say, in our country, we're concerned about the spreading and encroachment of desert areas or lack of access to water. We're concerned about invasive animals, maybe plants or pests. Perhaps we're also concerned about the needs of people who are in forced migration status. So of course, space technology can't perfectly solve all those things, but you can provide information and provide connection between people for communication services may help alleviate some of these challenges. This is a picture just highlighting the fact that when you bring all your stakeholders into one picture and try to understand how they're connecting with each other, it can get very complex. This is a picture showing actually a summary of all the stakeholders involved for a country starting their first satellite project in the late 2000s. And it just shows that in the middle you have the group that was actually building the satellite, and they were the ones who were leading the project, but they were working closely with a supplying company. They worked with many government agencies that were involved with reviewing the work, and they had a launch provider. So there was lots of connections, either exchanging political power or funding or information or financial connections across all these different teams. So even a relatively small-scale satellite project has a lot of stakeholders that have to be involved. So understanding the potential relationships and who is expecting what from whom is key to designing your space program. I'll give you some examples of how I've seen certain dynamics in past space programs. I've seen three key patterns that you may see in your work too. For example, sometimes when countries first start their space activities, they have a lot of political support because it's very exciting for a country to start their first space activity. If they're buying a satellite, for example, or having the first astronaut go to space, or sending a microgravity research payload to a space station, this is something that leads to a lot of political support and excitement. And sometimes that means that there's less detailed scrutiny of the technology. People say, well, this is great. We're going to celebrate this new opportunity for our country. And that means sometimes it's easier for the space leaders to fundraise. Maybe that first time they say, well, we're so happy to have this opportunity that we give a lot of initial funding from the legislative teams in the government or from the central body of the government. Traditionally, when people do this for their first satellite project, I've seen that that could mean that they have a relatively simple satellite, which actually can make sense because the goal is just to do more experience in space and get more familiar with the process of training engineers and getting involved. And of course, this can be adapted to other types of projects. And I've seen examples where people are buying a satellite and they're also paying to have engineers from their country get training in a foreign firm or a foreign government project or a foreign university, for example. And these are all options for how people can get started if there isn't yet inside your own country a program to train or educate engineers in satellite design or other space engineering. And I've seen two other models that are relevant. One's called service-oriented, one's called technology-oriented. In the service-oriented model, the idea here is that usually after the first satellite mission or big space activity, people think, well, we've already had one, so they're less concerned about maintaining another program. And it actually can be more difficult to fundraise or to convince government leaders that it's important to go to a second project. So in that case, I think it's important to demonstrate the value of the project to the people that have to approve it, whether they're in universities or companies or governments. And the fundraising then should either demonstrate it's going to bring practical service benefit to your country, or that it's going to be actually innovative technology development that also builds the knowledge and experience of the company and the country. And this can be done whether you're a university team or a government team, but you can either kind of pitch this activity as we're going to get high quality technology that will definitely bring useful services and it'll help to address some of the societal needs. Or you can say, we actually are going to explore new technology. It has some risk, but we'll definitely learn a lot and be a part of advancing the knowledge about space technology. Both of these arguments I've seen work effectively in different government contexts. I mentioned the topic of context, and these are additional questions, and you can find them in some of my recent papers, highlighting some of the detailed questions that need to be explored if you're going to ask what's happening in your own country, in your own organization, that might influence how you design a satellite program, microgravity research programs, or additional kinds of space activity, also in fundamental science. So it's a long list, and I won't read them all here, but it covers topics in technology, organization, kinds of facilities you need, the regulation. It goes on to talk about politics and economics. The idea here is that you can't just talk about technology, but you have to have a broad view of the social and political issues that affect a space program. Finally, I'll just give a few examples of some of the concrete models I've seen people use in thinking about how to set up their initial satellite activity. Some people work directly with a foreign firm if there isn't yet a firm in their country that's involved with space, and they actually are working to build a satellite as fast as possible and buying it directly from that firm. Sometimes local universities are the first movers to work on a space project, whether it's in a satellite design or it could be in fundamental research and astronomy. And other times there's collaboration between a local entity and a foreign entity where they work very closely together and both groups are involved. I've seen several countries in the Middle East take this approach. And I think they've used it very successfully to learn and then move more toward having local activities afterward. This set of guidelines is a summary of what I was just sharing, that when you're going through the process of imagining a new space program, you can start by understanding the satellite program context, then analyzing the needs of stakeholders and the desired outcomes. Select objectives that are feasible for your program. They may not meet all the needs, but they can help to advance them. And then you identify functions, what activities will your program do, and then identify the forms. What kind of organizations and people will you bring together? There's a couple opportunities, especially in steps 1 and 2, but also in steps 4 and 5 to ask, do you want to partner with international universities, organizations, and other groups that can give you more experience and help you build up the skills you want in your country to get started? You can also ask the question, how is it different to do an independent program versus a program with a foreign government, a foreign company, or a foreign university? And I have a paper I can share later, but the idea here is looking at different kinds of partners lets you see that they may have different reasons for partnering. So the foreign university, there can be great exchange between two different research scholars, and that is often a partnership that can lead to a desire to publish papers and to sort of educate people. If that's your common goal, then that's a very good fit. If you're working with a foreign company, they of course have the goal to make profit, but also to advance their business. So we want to see if the goals of your program fit the goals of that company. And looking with foreign government collaboration, those can be really excellent, especially when the two governments have common interest. But you also want to see how political issues may affect the planning, and also whether the timing may be slow because there's a need for developing political agreements. So those are all options, but they certainly have different impacts on how you move forward with partnerships. Partnerships are a very important part of space. So much of what we do throughout the space community is through partnership, either across government or commercial or university activities. I've really been pleased and honored to meet many of the leaders of countries that are starting space programs now. So just leave you with a few faces before we go to questions. These are teams in the country of Mauritius that are working on their first satellite program, and they will be starting space activities more and more in the country, and they have a tradition of radio astronomy. This is one of the professors there that's been very active in their astronomy activities in the past. In Chile, I appreciate the leadership of Marcos Diaz. He's a professor working on university satellite projects, and he's really been a leader in pioneering of local activity to build satellites in their country. Dr. Fula Muftau is an entrepreneur in Benin. He's the leader we work with on the project to monitor invasive plants right there in West Africa. And this is the National Remote Sensing Team in the same country. From Venezuela, I've been honored from the International Astronomical Congress to meet this engineer, Elika, and she has had a chance to work as one of the early teams doing satellite engineering in Venezuela. I also want to mention Hala, who's from the Sudan, and was one of the first engineers working on satellite projects, both in Sudan and later she had a chance to work actually at Kyushu Institute of Technology, where they have a great program to train engineers from around the world, and you can apply to that program through the United Nations. It's a great opportunity to learn satellite engineering in a hands-on way. I think I'll pause there and actually invite your questions, and just to say that there are people around the world just like you interested in bringing more space technology to their region, and many of them have found creative ways to do it, just like Hala has. And I think you can follow their example and be involved, whether it's through satellite engineering, whether it's through basic fundamental research like astronomy, or whether it's through microgravity research and human spaceflight. There's many opportunities opening up. Thank you so much, and I look forward to the questions.
Thank you very much, Professor Wood. Your presentation was amazing. It organized many ideas because from my side also, and I'm sure that many of the participants, we had 75 participants, by the way, many of the participants are also they are part of emerging space programs, and they want to bring space technologies to their countries. I will ask one question from my side, and then I will pick some of the questions in the chat. Of course, I would like to remind those who participated earlier that they can ask the questions in the chat, and I will try to mention the question to Professor Wood. So you mentioned basic science. There is always this argument against basic or solid science in emerging countries or developing countries that the investment is not very much feasible. It takes long term, and they prefer to go to applications more than solid science or basic science. So can you tell us examples how a space program can push or can expand research in solid science, and why it's very important to space programs?
Thank you so much for that question. I'm actually just adding a paper in the chat. So I want to encourage everyone to please follow the link that was just sent. It's wonderful to see that question, and I'm very thankful that you asked. So I want to highlight that I mentioned, of course, these 6 areas of space technology, and one of them is fundamental scientific research. I think if I go forward on the slides, we'll see something I want to share. The paper I just added is by a colleague named Jose Antonio Garidi, as well as several other researchers, Julio Pertuce, Sebastian Fotenhauer. Please do go to the link and download it. They make an argument around the opportunity to highlight the benefits of investment in fundamental scientific research. They're focusing on the example of the country of Chile. Now, of course, what they're highlighting is that Chile, for example, like Australia and South Africa and a few other regions, they're what's considered a natural laboratory, meaning they have a location in the country that has a great advantage for doing basic astronomy. So people from around the world work together to send and set up telescopes in Chile. But you could ask, is that benefiting actually people from Chile, or is it only benefiting people from around the world? So the government of Chile has had to say, how can they actually design national policies to ensure there are benefits to local people? One option is that they've required that for these international telescope projects, there has to be a minimum particular participation of people from the country. They're also asking how they can build local skills and activities in data science and in kind of computer science you need to look at large data sets. And actually, I've been interacting with some of the colleagues. They created a group called the Data Observatory in response to all the great astronomy data that they have. And now we're applying some of the same thinking actually to their COVID response. One of the great ideas is that there's been a lot of work demonstrating that any investment in basic research includes investment in people, in infrastructure, and in tools like computer science. It can support innovation in the country, but it has to be linked where there's a clear set of policies that say, given that we have the investment in basic science, Can it be transferred into other fields, or is there support for other activities, such as having great tourist locations near scientific facilities where you can also have economic spillover? So it's possible to do, but it requires some planning. And there's been some great scholars writing about this topic. Please see the paper for an example.
Thank you very much. That's very interesting. So now I would like to ask a question from the audience here, from Simran. So her question is, as an individual or organization, what are the strategies that can be implemented to request or influence the national government to support the new space programs?
Thank you so much. Before I go on, I just have to make a pause because it was really great to see something in the chat. We actually have Elika on, who I just showed on the screen. Elika, would you like to say anything while we're together? It's wonderful to have you on the screen. You want to just say something about what you're doing?
Hi, Danielle. So nice to see you.
So glad you're on.
Well, actually, I recently have like a big change of my life. I finished my master's degree in Beijing, and I moved to Peru. So right now I'm looking for like new opportunities around here, and I'm just like trying to keep, you know, what's going on in the area. Thank you.
Thank you so much, and congratulations on the graduation. That's great to hear. So glad the community is still keeping us together. Sorry about that, but since I show her picture a lot, I think it's wonderful that we could hear Elika's voice. That's great. Can you please repeat the last question?
Yeah, that's amazing. Of course, it's inspiring to hear from others, also PhD or master candidate, about their experience. So the question from Simran, she's asking, as an individual or organization, what are the strategies that can be implemented to request or influence the national government to support the new space programs?
Okay, thank you so much. And I'll just give another example of a paper that I've addressed this a bit. So let me pull that up for a second. I wrote a paper focusing on sort of, I called it architecture. I use this analogy in the talk, saying we can think of our design of a space program as an architecture. And the paper I wrote called Architectures of Small Satellite Programs in Developing Countries addresses this further. So if I can pull that link up. I recommend you check that one out because what it does is it highlights you'll need different arguments depending on the situation in the country. In some cases, the country will be, depending on the context that you're in, will be in a position where they already recognize the benefit and they're just looking to ask how to do it. In other cases, there's a need to further kind of convince people of the benefits and really talk a lot about what the outcomes will be for the country. So I just added the link, so please check that out if you'd like to read more. But that's why I highlighted the example of those two different cases if you're looking at a service-oriented program or a technology and innovation and scientific-oriented program. If it's a service-oriented program, the arguments have more to do with saying, if we invest in space technology, we'll get these concrete benefits, which could be better understanding of the environment, training for engineers and scientists, or better understanding of communication systems across the country. If it's a technology-oriented argument, you want to understand, will your audience be impressed by that? Will they appreciate the benefits of fundamental scientific research or of advancing new innovation? So depending on what kind of context you're in, what kind of political priorities are in place, what's happening in your country and your neighboring countries, you'll have to target the argument so that it matches. But there's several options from previous experience. You can see that in the paper here. If you have any trouble finding the paper, let me know and I can give it to you later on.
Thank you very much, Professor Danielle. So we have another question from Marco. He is asking, we are developing a study on tech implementation of the new space on development countries. I think he's saying developing countries, and we would like to know, on your opinion, what are the main reasons for failure of small versus big space programs?
Thanks so much. And I think there's a couple papers that I've written. I've written one called Sustainability of Small Satellite Programs, looking particularly at not so much failure, but I showed this story where sometimes in the very first project, there's a lot of political excitement, and so it's easier to convince whether it's political leaders, funders, and organizational leaders to be involved. So the longer a space program goes on, the more effort can be required by those who are involved with actually implementing space technology activities to convince others as stakeholders. So I think when there's leaders who are able to commit to several consistent projects that really show outcomes, that often leads to a lot of momentum and a lot of benefits where people who are trained are still involved, they're able to continue the work. And so I think momentum and sort of maintaining a steady flow of projects is very valuable, but it's not always possible. Sometimes there are major events, such as the death of a major political leader unexpectedly that affects the country's planning, or a major natural disaster that changes the priorities for the country. So when that happens, the space leaders have to be flexible and try to adjust so they can identify a new path to mix the space activities with the national needs. I think we're almost out of time, but let's take one or two more questions.
Yeah, if you have time, we would like to have maybe one question by Gonzalo, because I am sure that many of us also would like to learn about this part. So his question is, I wanted to ask if you see large benefits from young space programs focusing on deep space missions or space exploration.
Thanks so much for that question. It's definitely true that when I first started this research, I basically thought, well, new satellite programs will be doing small satellites orbiting the Earth, and that's all. But of course, we're in a new era, and people around the world are asking how small satellites can be used, not just in orbit around the Earth, but in orbit around the Moon and in deep space missions. And I think there certainly is an appetite for different kinds of space activities from what we've seen in the past, including innovations in deorbiting space debris and innovations in affordable activities on other locations, like on the surface of the Moon or in orbit around Mars. So I do think, especially through partnerships, it's possible to find opportunities when there's willingness across different parties. There's no reason to avoid or to ignore these opportunities. See them as learning opportunities, and whenever there's an agreement between different university parties or research organizations, I think it's a great idea to expand the definition of what we can do as emerging space activity. And I think whether it's focused on Earth-based applications or advancing science and technology and innovation, those are all exciting. And now I would say there's no artificial limit that we should assume for emerging nations.
Thank you very much, Professor Danielle. It's amazing to hear the answers from your perspective, of course. Unfortunately, I would like to apologize from the audience that we can't really take more questions because the time is already up now. It's the end of the presentation. However, very last question, there is a question here, how they can contact you, Professor Danielle, after the presentation.
Sure, I'll put my email address in the chat, but when I do that, I'm also saying I may not be able to answer you all right away, but perhaps what I do is I've actually noted the questions here in the chat, so that's great, and I'll consider some of those. And if you send me an email, what I'll try to do is actually, rather than answering everyone individually, I would rather have people, maybe I'll compile some answers and share it with SGAC leadership.
Yes, sure. So maybe they can send me the questions they have. I can compile the questions, and I can direct it to you, of course. So
that'd be wonderful. Thanks so much.
Great. So in this case, I will ask everyone to send me their questions. I can write down my email address. So please ask me the questions. I will answer you all. I will compile the question and forward them to Professor Danielle.
That was wonderful.
Yeah, thank you very much, Professor Danielle. Unfortunately, it's only 1 hour presentation. Otherwise, we would really love to have you for a longer time. If you have a last word to say for the audience, the floor is yours.
Thank you. My main message to all of you is please continue to be inspired and believe that you can play a key role in the future of space technology. We need all of you and your great ideas, and no matter what field you're from, whether it's engineering or science, humanities, policy, social science, history, all of that is important to designing our future to space.
Thank you very, very much. It was an inspiring presentation. Thank you for your time. And I would also like to thank SGAC team, the Middle East regional team, Ahmed and Saeed, for supporting to organize this event. I would like to apologize for the audience again. You can send me your questions. I will communicate with Professor Danielle. Here, I would like to end the presentation. Have a great rest of the day or have a good night, and see you later. Bye-bye.